Okay, Jim, for sake of example, what I've got again is a late model GM vehicle. I got a sudden drop in fuel economy, sluggish performance. So what I went and did is I pulled the codes out of the ECM. What I found was a code 33. Well, I referred to the manual on that vehicle. Code 33 told me I've got a MAP sensor circuit problem. Where do we go from there?
Well, that really doesn't surprise me because a MAP sensor can cause a drastic decrease in mileage and some sluggish performance. But I think what we'll have to do is test this. I would suggest a quick 2-minute test to verify that code before we go any further.
Okay.
Now, what we're going to need is a vacuum pump to supply the vacuum that the intake manifold would normally supply. We're going to need a voltmeter, and we're going to need some way to make it run. So I brought along a special tester for that. This is our universal tester again with the correct end on it for plugging into MAP sensors for this type of testing.
Okay.
So I'll get that plugged in, and perhaps you'd like to do the vacuum gauge while I get the voltmeter turned on.
What your MAP sensor does is it signals the computer as to how much load is on the engine, and therefore the computer adjusts the fuel mixture and the ignition timing to match that load.
Now what we want to do is watch the voltmeter here. As you apply vacuum, the voltage should change.
Okay.
And I suggest going to about 15 or 16 inches of vacuum and holding when you get there.
Okay, this is similar to our throttle position sensor test. You want to watch to see if the voltage changes evenly, and in our case it does, and I'm at 15 inches of vacuum, and it holds vacuum.
Right. After you're satisfied that the part doesn't leak at all, go ahead and release the vacuum, and the voltage should go back down to somewhere near where it was before.
And it does. Now this happens to be a MAP sensor off from a GM vehicle, and it's operating fine, so that is not our problem.
That's right. And since it's not our problem, on the vehicle you spoke about, we would have to go to our book that talks about diagnostic trees and trouble codes and find the MAP sensor diagnostic tree and just follow the step-by-step procedures for that MAP sensor. And what you'll find is that you either have a bad vacuum hose or an electrical connection, it could be an ECM again, but somewhere in there is where your problem lies.
Okay, so we know replacing the component at that point in time isn't going to fix our problem.
Right, although one day we found this one on a car that was bad, and let's show the folks how we found a bad one.
Okay.
Once again, we attach our lead. This one is from a Chrysler, by the way. And GM and Chrysler MAP sensors work the same way.
All right, I'll plug the vacuum hose from the hand vacuum pump in there. Now again, these tests can be done on the vehicle or can be done with the item off the vehicle like we're doing here.
Okay. Once again, the voltmeter is set on the proper voltage range, and you go ahead and apply the vacuum.
Okay, I'm applying vacuum. Nothing's happening. Nothing at all is happening. I'm at 15 inches. Now the vacuum gauge is staying steady, so the actual vacuum diaphragm in here is okay, but we've got an electrical problem with the MAP sensor.
That's right, Scott. The electronics in this device is not working, and that's why we don't get a voltage response. So this one is bad.
Okay, that would certainly create our problem. Now, what about Ford vehicles? They got something a little different, don't they?
They certainly do. This is the Ford MAP sensor, and although it's similar to the Chrysler and the GM in many ways, it's shaped a little bit differently. It has a 3-terminal connection and a vacuum port, but unlike the others, this does not change a voltage. This actually creates a frequency, and we have to read that on a frequency meter or even our tachometer. That'll work real well too. Why don't we go out to the car? There's one on the car. We can just test one on the car to show how it's done that way.
All right.
We'll need our
hand vacuum pump.
Right. We'll need our tachometer, and we'll also need our special tool with the correct attachment for the Ford, and I've got that right here. So let's take everything on out to the car.
Okay. Okay, Jim, here's our Ford vehicle. I'll set the vacuum pump here. And our MAP sensor sitting right back here up top, isn't it?
Sure is. Very easy to get at on this particular vehicle. Now, to test this, what we're going to have to do is first disconnect the vacuum line so that we can attach the vacuum pump, and the electrical connector so that we can attach the tester. Now, on this particular unit here, there is a little locking tab that you just push down with your thumb, and that aids in pulling off the connector. Now here we have our universal tester, and I'll plug the Ford MAP sensor lead to it. Now we don't use the light at all on this. All we're using this is for a power supply and a place where we can take the generated RPM and pick it up with the tachometer.
Okay.
Now let me explain that. First we'll simply plug into the MAP sensor, And then the MAP sensor is actually working now because we have our own power supply.
Sure.
It's producing a frequency based on what the MAP sensor is putting out right now. And for us to read that, all we have to do is take our meter and turn it to the 4-cylinder tachometer scale.
Okay.
Attach the positive and negative leads, and there we have our frequency.
Sure.
Now to change that, as the engine does, we'll attach our vacuum pump so that you can apply vacuum to cause the reading to change, and that way we'll be able to see if this MAP sensor responds to vacuum.
Okay, we're at about 491 just for reference point, and I'll start pumping it up. We'll see if it changes. And it is changing nice and slowly as I pump the hand vacuum pump up slowly. So what we're looking at is the electronics in it is working, and also the vacuum diaphragm is working. I'll stop pumping. We'll just make sure that diaphragm holds.
Right, watch the gauge for a few moments and make sure it doesn't leak down.
I can just release the pressure. We should be back about to our original reading, 490, and we are.
Right, so now we know we've got a good MAP sensor on this vehicle.
Testing your manifold absolute pressure sensor is easy. Let's look at the procedure involved in testing this sensor. First, connect the universal tester to the manifold absolute pressure sensor. Connect a vacuum pump to the vacuum port located on the sensor. Connect a digital multimeter to the sensor's electrical connection. Set the meter to the appropriate scale for your vehicle. Next, observe the reading shown on the meter. Apply vacuum to the sensor and note the meter reading. Typically, 5 inches of vacuum equals approximately 1 volt of change on the meter. Release the vacuum and observe the meter reading. It should be equal to the initial reading obtained earlier. If the sensor tests okay, refer to the proper service manual and follow the diagnostic chart for further testing.
To replace your manifold absolute pressure sensor, the tools you will need include a 1/4-inch drive socket set, a small regular blade screwdriver, a needle nose pliers, and the correct MAP sensor for your vehicle. The first step whenever working on the electrical system is to turn off all the electrical accessories, including the ignition key. MAP sensors and vacuum sensors, depending on the type of vehicle, may be mounted in one of 3 positions under the hood. Normally, they will be located on the inner fender, on the vehicle's firewall, or they might be located on the air cleaner housing.